Hello everybody, in this video I want to give you an overview of what databases are and a little bit about the database that we'll be using, and then towards the end we'll have a little experiment that shows you, should hopefully enforce the point as to why using databases is useful as opposed to storing data in some other kind of medium like text or Excel. So first of all is, what is a database? Well, a database is a very efficient way to store highly structured data for querying and data management. So what I mean by querying is really just question answering. So I have a ton of data and I want to ask a question about it. What's a good way to do that? And so that's a very high level. That's a very high level definition that I gave there. Maybe a more concrete thing to do would be to equate databases to a spreadsheet. So I have an example of an Excel workbook set up here. And so you can conceptually think of the data stored inside of a database as being kind of like in a workbook like this. So with a workbook, we have these different, down here at the bottom, you can see we have different sheets here. So I have one sheet that says track. I can go to another sheet that says album. This is really, let me make that a bit larger. You can see that. So I have another track that has all of the albums here. And then I can go back to track. So these are two different sheets, and in database lingo, these would be considered two different tables. And again, they're even organized kind of conceptually in the fact that they look kind of like a table here. Let me make this a bit bigger. So, you know, we have a header row here that tells me what each of the entries looks like, just like what you would expect in a regular table. And I have a bunch of these rows, which are entries in this table. Same for track here. I have a top. I have some information here that tells me, that gives me just basic information about what each of these columns means, and then I have, let me expand that out so it's easier to see, and then I have rows which are entries in this table. And so this database lingo also uses the same conceptualization of rows and columns. So a row would be a slice this way, and rows are just entries inside of these tables. And then columns represent things, slices across all of the rows. So here's a composer column, and inside of this column has all of the different composers for each of the particular pieces of information. So you can kind of conceptually think of a database as being organized in a spreadsheet fashion like this. Now, they have lots of advantages over just using spreadsheets that I'll get to in a second, but conceptually you can think of a database as being organized in this fashion, where each of the different sheets here represent different tables. So I have one table per sheet, if you want to think of it that way, and then each table has rows and columns, just like you would expect a regular table to do. Except the thing about databases is that they can handle millions and millions of rows in a very efficient manner. And we're going to run an experiment. We don't quite have a million rows, but we'll use something a little over 500,000 rows, and we'll see what the difference is if we use a database versus if we use a text file. If we store that in a CSV or a text file like that, and you'll see that there's a staggering difference in how long it takes to ask just a very simple question. But we'll get to that kind of towards the end. And so the thing about, like I was getting back to, databases are great for handling very large amounts of data, more so than spreadsheets can, and they're also much better at doing question answering or querying of this data in a very efficient and fast manner, faster than they're a bit more efficient than using spreadsheets. So I've been talking a lot about querying, and we also know the other purpose of having databases so we can manage them. But how do we do this? Well, we use a kind of language called structured query language, or SQL or SQL, and we can use that kind of language to ask questions or to query the database, as well as do kind of management things such as adding new entries, adding new rows into this database, maybe changing rows, getting rid of rows, and whatnot. We can use it also to create new tables as well. So the whole language we're going to be getting into, the syntax and such, is SQL, or structured query language, SQL. So we'll be using that. Now, there are a ton of different kinds of databases, and the one that we're going to be looking at is called SQLite or SQLite. And the reason that we're doing this is because it's very easy to set up and use. It's pretty much works out of the box. It's very popularly used in mobile development, actually. If you're doing anything with iOS and Android and you need some kind of data structure, usually what's used under the hood is a SQLite database, because it's a very small, compact database, so it's great for mobile devices. But don't worry, the SQL language that we're going to be using with SQLite is very transferable to other different kinds of database. So another very popular one is MySQL or MySQL. It's very popularly used in industry applications, and the SQL that you'll learn can just transfer directly over to MySQL, and then each database has its own specific kind of operators. So that also might be something you look into, but I'll try to keep this general enough that you can just take the knowledge that you learned for SQL and SQLite and move it over to another kind of database. So that's kind of just an overview of what databases are and how you can think of them conceptually. But the question you're probably thinking of is, why do we even need databases? I already have a spreadsheet here. What's the point of even having a database? Or maybe I can store this in a text file. What's the point of having this database and learning all this whole SQL language? What's the point of even doing all that stuff? So I have a little experiment set up here. So I have an example .database SQLite file, and I have a data.csv, which is just a text version of this database, and I have 2 Python scripts just to make it fair. And this db.py, what it's going to do is run the query against this database, and the text.py is going to run a query against the CSV file, which is this plain text. So the query that we're asking, so this database, by the way, I should mention, the database and CSV contain a list of different orders. And so the question I'm going to ask is to fetch me all information you can about the order whose ID is blank, and whatever the order ID I chose. And this is a very ubiquitous query for any kind of retail site. Anytime you're buying anything on any site, this kind of query is used all the time. Imagine making an order and you want to get some shipping information about it. You can go to the website, you can go to My Orders, and you click on that order. What's going on under the hood is we're doing the same query. We're saying, fetch me all you can about the order whose ID is this blank, whatever the order ID happens to be, so I can display it to the user. So this is a very popular query, and we're going to see the difference between using a database and using just storing our data in a text file. And so just to keep things on the same playing ground, I'm using Python for both. This is going to use the SQLite Python API to access this database and run the query, and the same query is going to be run using text.py against the data.csv, which has just the same information in my example.db. And I'm only running it against one table here, so this just has information on one table, and this is just going to query for one table. So we're going to time both of these and see how long it takes. So let's first time the text file. There's a Unix command called time that I can just run. We'll just say time Python 3 text.py. So I can run this guy, and it should spit out some time statistics. So here's the number that we're interested in is real. There's user and sys, but we're not going to get into that. The real time is how much time, like a wall clock, it's called wall clock time, so how much time has elapsed overall. So we see it's about 2 seconds, and we can convert this into milliseconds, so it'll be useful. So it's about 2,000 milliseconds. Okay, so that's how long it would take. And I should mention that the number of rows we have in this table that we're running the query against is a little over 500,000 rows, which, by the way, is not that big compared to the kind of data that we're working with nowadays, which is millions and millions of rows. 500,000 rows is nothing, So We have 500,000 rows, so we're running against this, so keep that in mind. Now I'm going to show you how fast we can get this working using the database. So I can run this guy, and you see this, not even 1 second, not even 0.1 seconds, but it ends up taking 64 milliseconds. So you can see this huge difference between using a text file and using a database here. So this is 2,000 milliseconds. I can convert to seconds by moving the decimal point over by 3, 1, 2, 3. So this is about 2,000 milliseconds. This is 64 milliseconds. So you can see the huge difference in time. And this is just for, again, this is just for 500,000 rows. The data that people work with, especially in industry, is on the order of millions and hundreds of millions of rows. So this shows you that using databases is a very good thing to do. They store data, they store and organize data very, very efficiently and differently, and they allow us to do very powerful queries. So this hopefully gives you some more background as to why we're even using databases and why it's important to do this. They're very efficient at handling large quantities of data, and we can ask all kinds of interesting questions about our data using databases.